Yeah, today no best. The reason for that is because I wanted to be looking very professional for meeting SLF 123. Max, at CLEO 2024, I'm meeting many of the executives of the Optica Corporate members coming all the way from Sweden. What's SLF?
So SLF is the Swedish Laser Factory, but we actually do nonlinear crystals. In particular, we do periodically poled KTP or Ppktp.
Why are you bringing Ppktp crystals to CLEO 2024?
So one of our biggest markets is actually the quantum market, so for generating entangled photons, and CLEO is a great conference for this because there's a lot of researchers.
When it comes to nonlinear crystals, you are actually talking to companies developing lasers for many different applications.
Yes.
What are the applications that make you more excited? To which ones can you make a stronger impact?
I think it's interesting working with people who do sensing, for example, because right now you have the global warming and things. So people who want to measure gas sensing, it's always fun to work with.
Ppktp is a nonlinear crystal that is coming here very strongly. I'm seeing lots of presentations in the program, lots of discussions. Why do you think that's because?
So I think there's for multiple reasons. So here at CLEO there's a lot of quantum things, and so Ppktp is very good for generating entangled photons, especially at the 405 to 810, but also the 775 to 1550. And KTP actually has an extremely flat dispersion for 1550, just a fluke, but it's very good. So for the telecom, you can get very nice spectral modes for the entangled photons.
In the quantum domain, we are seeing, as you said, very strong interest on the 405 nanometer wavelength.
Yeah.
What kind of things are companies coming to you with challenges and demands? What are they asking you?
So it's mainly researchers that are approaching us for these kind of things and ask us if we can do the type 2 or type 0. And of course we can do all kind of stuff that they might need.
Fantastic. And now we're going to see some of your crystals. All right, Max, so can you walk us through what you brought to CLEO?
So we brought primarily our Ppktp crystals, and one of the things that we can do, very cool, is the large aperture Ppktp. So we can actually pole crystals up to 4 by 4 millimeter apertures. So this is great for the high energy applications, but also for quantum applications if you want to have a larger beam through your, to generate your entangled photons. For example, for ghost imaging applications.
And you also brought custom and standard Ppktp.
Yes, so these are the standard size for most of the KTP that people buy is 1 millimeter thick, but for most applications it's exactly what you need. And what we also have is actually KTP crystals with a poling period that are hundreds of nanometer compared to normal, which is tens of micrometer, and this allows for counter-propagating nonlinear interactions. So where the signal and idler will go in different directions.
And you brought, of course, a demo unit, and with that demo unit is something that becomes available for anybody that wants to try it. What kind of people are getting access to this demo unit now?
So this is a fiber-coupled waveguide solution, and this is essentially to make it easier for the customers to just plug and play. So you have a fiber in and a fiber out, and you can just send your light into it, and out of it you will get a second harmonic, or you will get entangled photons if you're pumping it at
Max, thank you very much for being to CLEO 2024.
Thank you.
If you're looking for Ppktp crystals, you have to go to Sweden or you have to come to Optica here at SLF. Max, until the next time, let's meet some other people. That was really cool.